Ladies, gentlemen, it is time for us to learn a little bit of analytical trig. So you've got these notes in front of you, and we're going to jump right in here. I'm actually going to skip the first page, which is an investigation. And on the next page, I am going to explain the tools that we are going to use to play a game over the next couple of weeks. All right? The first kind of tool is called the reciprocal relationship. So this is saying that anytime you see sine, you could write it as 1 over cosecant of theta because sine and cosecant are reciprocals, right? And so here are all the reciprocal relationships. Over here are the quotient relationships. This shouldn't be a big surprise to you. You know that tangent is equal to y over x. So it's equal to sine of angle over cosine of angle. Likewise, cotangent is equal to x over y. Oh, I love that song. All right, let's continue. Here are some of the more interesting ones. These are called the even and odd identities, and they deal with a positive angle versus the negative angle. Imagine that we have an angle right here. Boom, 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 boom. And that angle leads us to a point on the unit circle, which is x, comma, y. Now imagine that we have the opposite of that angle. So if the angle goes like this, whoop, 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 the negative angle would go whoop, 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 the exact same distance, but in the other direction. Now, an interesting property happens when we draw this negative angle, which is that we get two triangles which have the exact same x value, but their y values are opposite because this y value is above the axis and this y value is below the axis. So the point where negative theta intercepts the x-axis would be at x, comma, negative y. As a result of this, we get some interesting properties. For starters, see that theta and negative theta have the exact same x value. So that means that over here, the cosine, because cosine is x, right? The cosine of negative theta and the cosine of theta are equal to each other. So those are positive. Same for the secant. Okay. For that reason, we call these even functions. This is something we talked about first semester, right? Even and odd functions. For sine, we know that sine is the y value. See how the y value of theta and the y value of negative theta are opposites. So we say that the sine of negative theta is the opposite of the sine of theta. And that will also be true for cosecant and tangent and cotangent. So these are your odd functions. These in the middle are your even functions. Moving along. Next one. This is called the co-function identities. And it goes a little something like this. I'm going to draw a triangle. And let's suppose that we call this angle right here theta. Then this angle right here would be 90 degrees less than theta. So for instance, if this was 40, this would be 50. If this was 30, this would be 60. If this was 20, this would be 70. You get the idea. So this is 90 degrees minus theta. But since we tend to deal with radians, I'm going to write this angle as pi over 2 minus theta. Okay. Now, we've got these boom, 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 these three sides here, right? Let's just look at this first example. Suppose I wanted the cosine of theta. If I called this side A and this side B and this side C, wouldn't the cosine of theta be equal to the adjacent, which is A, divided by the hypotenuse, which is C? Ooh, 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 ooh. But check this out. Let's go to the other angle. For this angle, A over C is also a relationship, but it is the opposite. Ooh, let me say that again. It is the opposite divided by the hypotenuse. Well, what trig function relates the opposite to the hypotenuse? That's sine. So for the angle pi over 2 minus theta, a over c is the sine. Therefore, the sine of pi over 2 minus theta and the cosine of theta are the same. It turns out that this is a property that is true for all co-functions. So the co-function of sine is the cosine. Therefore, we get this property. Below, the cosine of this angle is equal to the sine. And so as we fill in the rest of these, we're going to say the tangent of pi over 2 minus theta is equal to its co-function at theta. Cotangent is going to be tangent of theta. And secant is going to be cosecant of theta. Cosecant is going to go with secant of theta. Okay. So those are called our co-function identities. Now, flip the paper over, and I'm going to show you how we are going to use these. On this page, there's a whole bunch of trig expressions. And in each one of these, I have a challenge for you. I want you to use the identities that we just looked at on this page, in order to simplify these expressions so that there is only one trig function in it. So if you look at this one right now, we've got two trig functions. We've got tangent and cosine. We want to get that down to one trig function. All right, well, the first thing I would do is look at cosine of negative x. Since you see a negative angle right there, you know that this one is going to be some kind of even or odd function. Well, what was cosine? Was that even or odd? Let's take a peek. Cosine's even. So you can replace the cosine of negative x with the cosine of x. Let's do that. So I'm going to take this expression, I'm going to rewrite it as the tangent of x is multiplied by the cosine of positive x. And again, we can do that right there because cosine is an even function. So that's step one. Now we've still got two kinds of trig functions. So let's keep going. The next thing I'm going to do is use a quotient identity, which says that I can take the tangent and I can rewrite it as sine of x divided by cosine of x. So at this point, you should see that we have cosine over 1 and sine over cosine. So right here, there's a cosine over cosine. Now I'm going to take more steps here than we usually need to, but this is just to kind of emphasize what's going on. That would mean we could write this as sine times cosine over cosine. I just moved this cosine over here. And since this is just a funky way of writing 1, what we really have is sine multiplied by 1, which means that this expression we started with is just equal to the sine of x. And now we met our goal. We've simplified it down to a single expression. Let's keep going. Try another one. Number 2. Number 2 says cotangent of x times tangent of x. And we see that we've got that negative angle again, which means that we're thinking about evens and odds. Now in this case, tangent is an odd function. And because it is an odd function, if I make the angle x positive, I need to stick a negative in front. So we're now looking at the cotangent of x is multiplied by the negative of the tangent of x. Next step, I'm going to do a couple of things here. First is I'm going to take that negative and I'm going to put it up front, so negative 1. Second thing I'm going to do, I'm leaving the tangent alone, is I'm going to use one of our reciprocal identities here. Cotangent is equal to 1 over tangent of x. Oh, so this is really similar to what we were seeing right here with cosine and cosine. And those basically canceled to give us a 1. Same thing's going to be true here. This is going to cancel with this. And we're left with just negative 1 times 1, or -1. Okay, so there's our answer, -1. Let's do a couple more. Take a look at number 3. Okay, this one's getting a little more interesting. On this one, I'm going to start right here. We know that this is going to give us some kind of co-function identity. And the co-function of sine is cosine. So this expression is going to rewrite as cosine of theta minus, I'll leave that blank in the middle for a second. This is going to become cosine of theta. In the middle, since we've already got a cosine and a sine and another cosine, it would make sense to take this cotangent right here and rewrite that using one of the quotient identities as cosine of theta over sine of theta. So look at what's going to happen. Those are going to cancel, and we're left with cosine minus cosine plus cosine, which 1 minus 1 plus 1 is just 1. So this is just equal to the cosine of theta. One last problem we're going to do today. Take a look at number 4. On number 4, tangent can be rewritten as sine of beta over cosine of beta. By the way, I'm using a strategy that you're going to see over and over and over again, which is when you have an ugly mess like this, you're going to make everything sine and cosine. Also, some of you are looking at that beta and thinking that's kind of freaky. Listen, it's just another variable. It's a Greek letter that we use as a variable. So cosecant is going to be 1 over sine of beta. And cotangent is going to be cosine of beta over sine of beta. So, I notice something. I notice that this and this have the exact same denominator. So we could rewrite this as the sine of beta over cosine of beta is multiplied by a single fraction. And I don't need the parentheses anymore because the plus is just going to go up here. Same denominator means we can rewrite this as sine of beta. And in the numerator, we have 1 plus cosine of beta. And now you're going to see that a couple things are going to cancel. This is going to cancel. This is going to cancel. And we're left with 1 plus cosine of beta over cosine of beta, which I guess meets our conditions because our goal is to get this down to one kind of trig function. But I do want to show you that we can make this even nicer. What we can do is we can say that cosine is going to divide this. So we have 1 over the cosine of beta. And then this cosine right here, it's also going to divide this. So we have cosine of beta over cosine of beta. So this whole expression is going to simplify down to 1 over cosine is secant of beta plus 1. Okay, so there we have it. We've done 4 examples together. Your home fun's on the next page. I'm going to flip it over. Bum-bum. Oh, I lied. It's not on the next page or the one after that. It's actually right here. On this page, it would be a good idea if you attempted number 1, number 2, number 4, number 5, number 6, and number 7. Give those 1, 2, 3, 4, 5, 6 problems a try and see what you can do, and then we'll talk about them in class next time. Okay? That's it for our lesson, ladies and gentlemen.